All right, today we're going to look at surface area, total surface area of prisms. First of all, what is a prism? So a prism is a shape that looks somewhat like this. It can be cut and the pieces repeat itself. So the cross section has a uniform shape. So if I cut the first piece, it's going to create, oh, hang on, let me put the pen out. So if I cut the first piece, it's going to create triangles after triangle after triangle. If I cut this one, it forms the same rectangle over and over again. And same with this one. I'm going to form the same hexagon over and over again. So these are prisms. However, if you look at these shapes, these are not prisms because if I cut them, I cannot get the same shape. It's smaller and smaller and smaller. This one is little circles to bigger circles to little circles. The shape are not the same, so they're not prism. These are prisms. So let's have a look. These are all prisms. Again, the shapes are repetitive when you cut them. The cross section is the same. Okay? You can cut them and they all look the same. So prisms and more prisms. The only two words I'd like you to know is this is a triangular prism. This is a rectangular prism. Let's have a look at examples. So I give you a couple of seconds to have a look and see which of these are prism. So let's have a look. Is this a prism? The first one here? Yes, it is, because you can cut them into the same square over and over again. The second one, not a prism because it's a 2D shape. The third one, this one here, not a prism because you can't cut them into the same shape. That one there, not a prism, again a 2D shape. This one here is a sphere, not a prism. This one is a prism because you can cut them and have the same circle over and over and over again. So this one is a prism. That one is not a prism. This one is a prism. This one, not a prism. This one is a prism. Oops. This one, again, it is a prism. You can cut them that way and you have the same triangle over and over again. That one, not a prism. This is a prism. Not a prism. Yes, a prism. And definitely another prism. Let's have a look at how we calculate the surface area. Now this is a cuboid. All the sides are the same. So let's look at how we calculate this. So let's count them. There's one piece, one at the back, one on top, one at the bottom, one to this side, and one piece to that side. So there's 6 altogether. So there are 6 times these squares. So in other words, you have 6 times 8 times 8 because the area of a square is 8 by 8 width times width. So now we have 6 by 8 by 8. Without the calculator, we have 384, and I would lose half a mark there because we haven't got the units in. Okay, now let's have a look at the second one. This one is a little bit different. We have a front piece, A. Let's call that A. And the back piece is exactly the same. Now we have this side piece. Let's call it B, which is the same as this side over here. Let's also call that B. We have a top piece. Let's call it C, which will be the same as the bottom piece, C, over here. So we have 6 pieces again, but they're different this time. So let's see. We have 2 of A and 2 of B's and 2 of C's. So you may write it like that, or you're welcome to write as 2A plus 2B plus 2c. So let's have a look at how we show the working out. So if you label it like that, label it with the ABCs and then write down your working out there. You don't have to work them out individually. You can put them all in one sentence. So A, what are the measurements of A? We have 3 by 9. So we have, let's use square brackets and round brackets, 3 times 9. 9 plus, what is B? B is 2 times, how tall is it? 9. 2 times 9 plus, what do we have for C? C is down here, we have 2 times 3. Okay, that's one way to write it. If you want to write it as 2 times 3 times 9 plus 2 times 2 times 9 plus 2 times 2 times 3, that's okay too, but it might take a little bit longer. So looking at this one over here, this middle working out, a good way to check it and to avoid lots of silly mistakes is to see that the 3, 9, 2, 9, 2, 3, none of these pairs repeat. If you accidentally do 2, 9, 2, 9 or 2, 3, 2, 3, that means you've accidentally looked at the wrong measurement. So have a quick check. They all look like 3 different rectangles. And now we can calculate it. So 3 times 9 is 27 plus 2 times 9 is 18 plus 2 times 3 is 6. Now let's add them all together. 27 plus 18 is 27 plus 8 is 35 plus 10 is 45. 45 plus 6 is 51. So now 2 times 51 is 102. Again, don't forget the units. Millimeters squared, because we have millimeters there. Take your time having a go at this question again. You can pause the video whenever you want. So with this one, if you chuck in the calculator and write 102 millimeters squared, you still get the mark. So 1 mark up here for working out and 1 mark here for the answer. Now, one last one before you can go off and do your own work. So how many pieces do we have now? The front piece, let's call it A again, which is the same as that one there, the back. Now, how many different pieces do we have? Be very careful that this 3 is representing the height of the triangle. The side of the triangle is given by 4. So we have this rectangle here. Let's call this B. The bottom, let's double check that they're the same. So this piece here is 11 by 4. The bottom is also 11 by 4. So let's call it B again. It's the same measurement. And then the back here, it's 4 by 11 again. So let's call it B again. So we have, let's clear it up a little bit. It's a bit messy. We have, oops. We have A's and B's. So we have 2A plus 3B. So let's work it out now. So the 2 A's are the triangle. So the formula for a triangle is half base times height plus 3 of B's are rectangles, which is length times width. So now we have the formula. Let's plug in all the numbers. 2 times the base of the triangle is 4. The height of the triangle is 3 plus the length of the rectangle is 11 times the width of the rectangle is 3. So now we have 4 times 3 is 12 plus 3 times, oops, hang on, I've made a mistake, very common mistake. This is supposed to be 3, that is supposed to be a 4. So let's get rid of that. Let's fix it up. So 4, because again, I was looking at height when really I should be looking at the side. So 4 times 3 is 12, times 11, 12 times 11 is 132. So now we have 132 plus 12 is 144, and the units are meters squared. That's it. So have a look at your book and do whichever questions you feel like it suits you most. Remember, you don't have to draw these ones, but when you get to the worded questions, I do expect to see a diagram. And do label your diagram properly. If you're not drawing the questions, let's say you're doing this question here, if you're not drawing it in your book, you would write question 1, part C. You need to show they're working out. How do you do that? 2 times. So you write down all the values accordingly. What do we have? O times. Let's move this over here. So 0.8 times 1.1 plus 1.1 times 1.3 plus, which one did we miss? The bottom, please. 0.8 times 1.1. So we've got all the 3 combinations. And then equals answer, and the units are meters squared. So I expect to see this working out in your textbook. See you back in Google Classroom. I hope the explanation was clear enough for you. If you want to watch it again, you can do so. On YouTube, you can click on the speed. So if you feel like I'm explaining too slow, click on the faster speed. And obviously, if you feel like I'm going too fast, you can click on the slower speed. See you in Google Classroom. Give me a comment on the questions if you have any, or let me know if that was clear or confusing, and send me an email if you're really stuck. Bye, guys.